Hello, welcome to my math
closet.
Welcome to my math closet. Today, we're going to be talking about simplifying radical expressions with variables.
Radical.
So, just to recap, a radical in math is this sort of checkmark looking thing with a little extension. And what that does is it says anything inside here that is the product of something times itself, that's going to come outside. And so, simple example, something that should be familiar to you guys, you have something like radical 25. Well, we know 25 is the same as 5 times 5. I've broken down this 25 into its prime factors, 5 and 5, and once you have a pair, they can come out. So radical 25 is the same as 5. Cool. So we're going to take that same idea and extend it to see what happens when the thing inside the radical symbol, the radicand, what happens when that has a variable in it. What does that mean? So if something like x squared is in here, well, let me see if I can break down x squared. X squared is the same as x times x. I've broken down this term as much as possible. I can identify a pair of factors there, and once I have a pair, they can go outside of the radical symbol. So the square root of x squared, that's x. Same idea as when we had 25. We broke down 25 into 5 times 5. I see something times itself, so it can come out. Just because I don't have a number doesn't mean I don't have something times itself. X squared is x times x, so I can pull the x outside of the radical symbol. I'm going to walk you through a few examples of this so you can see how it works. This one's pretty straightforward. You'll see that here we have a radicand of 49x squared, and so we're dealing with a number and a variable. But we just break them down piece by piece. So what I mean by that is we have this 49, and I can say, well, I know 49 is 7 times 7, and I have x squared, and just like we talked about, x squared is x times x. I have all prime factors, and so now I look for pairs. So I see a 7 and a 7, that's one pair, and I see an x and an x. That's all the terms taken care of. So the square root of 49x squared is 7x. 7x times 7x equals 49x squared. Okay, let's try one that's a little bit more complicated. Here we have a radicand of 12x cubed. And so just like before with 49x squared, I want to break down this term as much as I can. So I have a 12, so I can pull out a 2. I know 12 is 2 times 6. And then I have a 6 that I can break down into 2 times 3. So I've broken down the 12 as much as possible. Now I want to break down this x cubed. X cubed is the same as x times x squared, and x squared is x times x. I look along my factor tree. Every single term at the bottom is broken down as much as possible. So now what I'm going to do is I'm going to look for pairs. So I see a 2 and a 2. There's one pair. And I see an x and an x. So those are the parts that I can pull outside of the radical sign. But knowing that I do have some left over, that means that my simplified form is going to still have a radical sign in it. So I pulled a 2 out, so that can come out here, and I pulled an x out, so that can come out here. But what has to stay inside is that 3 that didn't have a pair. So 3 is still in there, and there's still one x left over, and that's got to stay in there as well. I wanted to take a second to talk about what happens when the power on your variable term starts getting pretty high. So here you'll see x to the 6th. And remember, when something is raised to a power, that just means that it's being multiplied by itself a certain number of times. So in this case, it's x times x 6 times. So if we think of breaking this down, I can break it down into, let's see, 1, 2, 3, 4, 5, 6, right? This is x times x times x times x times x times x 6 times. If we use that same idea of looking for pairs, well, we have 2 here, that's 1 pair, 2 here, that's another pair, and 2 here, it's a 3rd pair. So I have 3 pairs, and that means I can bring 3 x's out. And so what comes out is x times x times x, or x cubed. So what we end up with there is that the square root of x to the 6th power is x to the 3rd power. And to help you see how that makes sense, remember that what the radical sign does, what the square root does, is it says what in here is something times itself. So if we are saying that the square root of x to the 6th power is x to the 3rd, well, let's see what happens when we multiply x to the 3rd power by itself. X to the 3rd times x to the 3rd. If you remember your exponent rules, when you are multiplying a term with the exponent, you add them together. So x to the 3rd times x to the 3rd, that is x to the 6th, just like we started out with. All right, last example for you guys. This one, you'll see that there's already a 2 sitting outside of the radical sign. We're gonna ignore that for now and come back to it later. And inside the radical, we have 18x to the 5th power. We're gonna break down our radicand just like always. We're gonna see 18 is 2 times 9, and 9 is 3 times 3. And then I have x to the 5th, which I can break down into, we'll go 1 by 1, just to be extra clear. X times x to the 4th, which is x times x to the 3rd, which is x times x squared. And finally, x squared is formed by x times x. So I've broken down this term as much as possible, and then I'm going to look for pairs that I can pull out. I see a pair of 3s right here, and I have a bunch of x's, so there's 1 pair right there, and another pair right there, and 1 left over. So to fully simplify this, we need to remember that when we pull terms outside of the radical sign, that's multiplication that's going on there. So we had a 2 already, and so that 2 is still going to be outside. And then we're going to pull out a 3, so we're going to multiply that 2 by 3, and then we pulled out 1x, 2 x's. So times x, and then we got to see what is left inside. We have this other 2 that's still there, 2 times, and this other x that is still there. So if we simplify all of this, we're going to have 2 times 3 is 6, x times x is x squared, and then our radical sign and inside is 2x.